Hi everyone, my name is Paul, and I'm going to be talking about Spring into Kubernetes. So I'm going to start by talking about Kubernetes and giving you a run-through of what it is and how it works. And then I'll show some demonstrations of using it. And then we'll talk a little bit about Spring Cloud Kubernetes and how it lets you integrate your Spring application directly with Kubernetes. So this is me. I'm on the advocacy team at Pivotal, and what that means is I travel quite a lot to talk about Spring and to talk about Kubernetes. And in fact, unlike everyone else on my team, I'm not a software developer by trade. I come from a systems background, so DevOps and stuff like that. By the way, I wanted to thank you for letting me speak in English. I really appreciate that. It would be a much shorter talk if I had to speak in Korean. If I am speaking too fast, because I do tend to talk fast, feel free to throw something at me or yell at me and try and get me to slow down. You in the front row, it's your job to keep me at a good pace, okay? So I guess we can jump straight into Kubernetes. Who here has run Docker before? Just straight containers, Docker containers? Okay, not too many people, but a few. So has anyone actually used Kubernetes and actually run software in Kubernetes? Okay, again, a few, so that's good. My friend Corey Quinn likes to say that Kubernetes is named after the Greek god of spending money on cloud services. And if you've run Kubernetes, especially on one of the public clouds, it's very easy to run software, which makes it very easy to consume cloud resources and rack up quite a large monthly bill. So this is quite accurate, but not in a bad way. It's because it's so good at running software that you tend to run more software. So it's a good thing that you spend more money on cloud resources. Kubernetes is kind of on this range of platforms where over at the far end, you have like an old school hardware platform where humans do all of the work from plugging in hard drives, installing Linux, installing applications, all the way to this side, which is like your application platform, Cloud Foundry and Pivotal platform, and then the newer stuff like function platforms. And as you come in this direction, you give up some control, but you gain tremendous efficiencies. So with Pivotal platform, Cloud Foundry, you don't need to do a lot of work to get your application running in production. You just write your code, you run the CF push command, and it somehow magically figures out how to run your software. So you take a step back from that, and you have like your container platform, which is where Kubernetes sits. And it gives you a little bit more control over your application than Cloud Foundry. So you have more freedom in how you write your code. You don't necessarily have to follow all of your cloud-native best practices, your 12 factors. So it's kind of the perfect place for a lot of us to run our applications because we do get that more control. And it's also the perfect place for us to run higher-level platforms like Cloud Foundry on it. And that's why Pivotal's investing heavily into both Kubernetes and looking at moving our existing platforms on top of Kubernetes so we can take advantage of the things Kubernetes offers us. But I will be pretty specifically talking about Kubernetes and that container platform side of things. So to talk about containers, of course, you kind of have to start talking about Docker. Containers existed long before Docker came about. And in fact, Pivotal was building containers with our platform 2 or 3 years before Docker was even a thing. But Docker brought us a standard container, and so most folks now, when they talk about containers, are talking about Docker containers. And so a container is similar to a VM, but it's much smaller. It doesn't have the entire machine virtualized. It shares a kernel with the host operating system, and then only has the differences between it. So it's much smaller. In theory, you can pack a lot more onto a server, and it's a lot more efficient. There's a bunch of reasons. I kind of just said a couple of why you would run containers, but we'll skip through this, and we'll have a look at this. So this is a Docker file, and it's how you describe how you want your image to be built, how you want your Docker container to be built. And so you can see it looks a little bit like a script. So you can think of it as a simplistic like bash script. And you start at the top, and this is what's called a multi-stage Docker file. So we're starting at the top, and we're starting with a Maven JDK. We're copying our source code in, and we're running Maven install, and we're skipping tests because you should have already tested it before you're doing an image build. And then we're then starting from a smaller JRE image, and we are copying the built application that the Maven install built into that smaller image. And then we're telling it how to start. And so that's really all there is to build an image. And doing a multi-stage build like this means you can have a larger image that has your compile runtime, and then a smaller image that has just what you need for your actual application runtime. And so if I could, if I wanted, just use that top section, I would end up with a Docker container that's maybe 1 gigabyte in size, so quite large. Whereas by then moving my built jar file into a slimmer JRE, I'm looking at 200 meg, so quite a large reduction in size. And so it's important to, whenever you're building Docker images, you want to shrink them as much as possible, because Kubernetes tends to pull and push images around a fair bit, and so the larger they are, the longer it takes for it to do some of the things it needs to do. And so the important thing when you're building images is to make them as small as possible. Some folks will even run images that have just a single binary in them and no other Linux pieces. You don't have to go to that extreme. Sometimes it's nice to have some Linux tools in there like ls and things like that. So if you need to, you can explore the container and do some debugging. When you're using Docker, you run commands like this. So like build, push, pull, run, right? So fairly simple, fairly self-explanatory, and what we would call imperative. So if I were to run that Docker run command 10 times, I would have 10 copies of that container running. So that's what we call an imperative way of talking to software. So as well as using a Docker file, there are tools within Java that let you build Docker images in a more native way. So this is one example, and this is the Google Java Image Builder. And if you add this to your POM, when you do a Maven build, it will actually create a Docker image for you and push that image up to a central repository without you even needing to have Docker installed on your laptop. So that is very useful. And you get about the same size image as if you used the multi-stage Docker build. So a lot of folks are now starting to use tools like Jib to do the Docker builds for them. And all of that, like those Docker run commands, are great if you're running things on your laptop right here. But if you want to actually run things in production, you're going to be running them in a data center. There might be tens or hundreds of servers, and there might be thousands of applications, thousands of containers. And doing Docker run doesn't really scale to that, right? Because you have to do it on individual servers and sort of be your own scheduler. And so that's where Kubernetes comes in. And Kubernetes takes that idea of running Docker images and figures out how to do it across an entire data center worth of servers. This is, at a very high level, what Docker looks like. So you can see we have a control plane and a data plane. Data plane is where your containers run, and control plane is all of the bits that Kubernetes has that makes it happen. The really important things I feel that make Kubernetes what it is are the two controller managers. So controller manager and cloud controller manager. And they're what separates Kubernetes from being just a container scheduler into being a very powerful platform for running applications. So controllers form a loop. And basically, when you give Kubernetes a command, it stores what you want as a desired state, and then the controllers kick in. And they look at the actual state. If it's the first time, there is no actual state. So it will then act on that actual state and make it match your desired state. And then it will keep comparing the two, and anytime they're different, it will then work on the actual state again to match your desired state. And so you get this like auto-corrective behavior because it's always ensuring that what you have is what you asked for. Docker controllers Kubernetes controllers also follow the Unix philosophy of doing one thing and doing it well. So they tend to be fairly small applications with very tight focus on functionality that you can then tie together to have more advanced functionality. To communicate with Kubernetes, to give it commands, you use this kubectl command. Some people say kubectl, some people say kubectl. I don't really care how you pronounce it. Some people like to get into a long argument over the pronunciation. So I'll say kubectl, but you say it however you like. And like Docker, there are some simple imperative type commands you can use. So kubectl run, kubectl scale, kubectl create. So these are, again, imperative commands. If I run that kubectl run 10 times, I'll get 10 copies of that running. I can also use declarative. And with declarative, you basically provide a manifest that is exactly the desired state of your application and the resources that are needed to run your application. And you can do it in YAML or you can do it in JSON. And you have this file, it's a text file that is stored in version control, and it becomes your configuration as code. It becomes that thing that you can act on in a GitOps style workflow that you can push, use Jenkins or Spinnaker or some other tool to do continuous deployment based on what you have in source control versus you having to type things on your keyboard constantly. So usually when you're doing things in production for real, you would use this declarative style of working, whereas if you're doing something on your laptop, you're just testing something out, or you're up on a stage giving a demonstration, you might use the imperative commands to do things. And a Kubernetes manifest looks like this. You can see we kind of have these 4 major sections: API version, kind, metadata, and spec. So they're pretty obvious what they do. Metadata is a name and a set of labels, and a spec is literally a YAML-based representation of the API spec for the type of resource that you're requesting. This here is a pod, so it's the most basic type of application where I'm just specifying the image that I want Kubernetes to run for me. And then I would pass this on to Kubernetes using kubectl, and it would run this application for me. There are 3 main resources. There's dozens of them, but 3 that are really important to get an application running. We've got pods, which is your container runtime, services, which is networking, and volumes, which is storage. Pods are the execution environment in which your code runs. And it can be 1 or more containers, and they share a network, so they share an IP address, and they share a local host. And they also share storage. So you might use more than 1 container in a pod. If you have, say, a PHP app, which is 2019, you probably shouldn't still be running PHP, but some of us are, in which case you would have like Nginx or Apache in 1 container, and you might have PHP FPM in another container, and they would talk either over a socket that's on the shared disk or over a network port. So that's one example. You might have more than 1 container in a pod. But it is important to think of a pod as the minimum scalable unit of your application. So in that PHP example, you wouldn't also put a database in that same pod. You would put a database in a separate pod because they're different scalable units of your application. So let's actually start doing some demos. So I'm going to switch to a command line. Can you all read this? Is this big enough? Yes? Okay. So we're going to go ahead and I'm going to create a deployment, right? So I'm running kubectl create. I'm giving a name hello, and I'm pointing to the image that I want it to run. And Kubernetes will very quickly come back and say it has completed it. So if I ask Kubernetes what is actually going on, and I have k alias to kubectl, so I might type k, but it's the same thing as typing kubectl. So if I say kubectl get all, it's going to show me all the resources that are running in the namespace that I'm using. So you can see I ran a create deployment, but I actually have 3 resources. And this is our controllers in action. So we have our deployment, which was what I created. And that deployment is responsible for the complete application lifecycle of your application. And so it then will create a replica set, And that replica set is responsible for ensuring that you have a set number of copies of your application running. Now, I didn't specify a number when I did the create, so it's going to default to 1. And so that replica set then manages 1 or more pods. And so if I wanted to, if I have a big sale coming up and I wanted to scale it up, I could say create 6. So I'm telling Kubernetes that I want 6 replicas. So if I clear this and do the get all again, you'll see I now have 6 pods. They're already up and running. And so I have 6 copies of my Hello World app running. And you can see my deployment shows that there's 6, and there's 6 that are available, and so does my replica set. So that's kind of showing the scaling happening. Now, if I go ahead and pick one of these at random, let's pick the oldest one, and delete that pod. You might expect that we would now have 5, and so we'll see how many we have. So you can see we still have 6 pods, and that's because the deployment controller and the replication controller, you've asked for 6. I said kubectl scale. So because the deployment expects there to be 6, it's going to ensure there's always 6 running. So if I delete a pod from under it, the deployment doesn't know. Its desired state is still 6, so it will immediately create a new pod and ensure there are those 6 running. So you get that auto repair. If a node fails or something else happens that causes a pod or more than one pod to be destroyed, Kubernetes will immediately work to resolve that and fix that by bringing up more copies of that pod. And then we can actually edit our pods, so edit our deployment. So because a deployment is responsible for the application lifecycle, it will actually perform a rolling update of your application. So if I actually edit my deployment, and then so this is the desired state that's stored in Kubernetes. So I can modify it like this. And so what I'm going to do is I'm going to come down here and I'm going to add an environment variable. If I remember my syntax correctly, value. All right, so I'll save this and we'll hopefully see that change happen. So that is all I need to do. Normally, you'd be doing something a bit more interesting, like pushing a new version of your application. But for the demo, it's just easier to show an environment variable change. So if I do a get all again, we see we now have 6 running. But you can see they're all a lot younger. And you can see we have 2 replica sets now, one of which is the old one that had been running for 3 minutes. That is scaled down to, let me just make it a little bit wider. And it's scaled down to 0. And you can see the new replica set has scaled up to 6. So what happens when you make a change to your application is the deployment controller will create a new replica set of size 0. And then it will add a set number, say 2, and then delete 2 from the existing deployment, so that there's always a total of 6 running, and it will roll through until there's 0 left of the old replica set and 6 of the new replica set. And so that means me as someone who deploys software, I don't have to think about how to perform that rolling upgrade. Kubernetes manages it for you. Back when I used to write Chef and Puppet, I would write hundreds of lines of Chef code to try and do the same thing that just happens automatically with the platform. And so that's super powerful and really important for me as someone who operates a lot of applications on a cluster to be able to just let Kubernetes deal with that work for me. Now, accessing my application. There's no IP addresses. I'm looking at all my information here. No IP addresses, no host names. There's not really anything telling me how to access my application. And that is because I haven't yet created a service, which is what gives me the network connectivity to and from my application. So before I create a service, I can show you what's called a port forward. And so I'll pick a random pod. Oh, nope, that's not there. And then port 8080. And so when you do a port forward, it actually forwards a port from your local host into the local host of the pod that you've chosen. So this is a good way to just check that your application is working properly. So I can do a curl of localhost 8080, and I have that response. So that's what I put in the environment variable. So that's showing that the deployment definitely did its job, and I'm running the correct version of my application. But it's not cool to tell all your customers you have to run kubectl port forward to access my application. Not a lot of people will be happy about that. And so we have to create a way for folks to be able to access your application via normal ways. And you do that with a service. So let's just scoot this along a little bit. And we'll just go ahead and create the service because it takes a moment. So here we're running kubectl expose. We're specifying our deployment of hello, and we're specifying a type of load balancer, and we're providing the ports that we want to balance to and from. And so now if I do a kubectl get all, you'll see along with the pods, replica sets, and deployment, we have a service. And we can make it a little bit easier to read. Let's just look at the service itself. And so what we have is we have a service that's also called hello, and it has a cluster IP. And that IP address exists only inside the Kubernetes cluster, and it will load balance for all of the pods in the replica set, in the deployment. And so if I have two applications in the cluster that want to talk to each other, they will communicate over that cluster IP. And in fact, they can communicate to each other using the name of the service, because Kubernetes creates DNS names based on the names of the services. So if I had another application that needed to talk to my hello application, I could simply give it the URL hello, and it would figure the rest out. And that's pretty great. We also have a list of ports. So if you want to access it from the outside world, you need to access it via like one of the worker nodes or an external IP address. So what Kubernetes will do is it creates what's called a node port. And that is an ephemeral port, so 30834, and it will map that to the pod port on every worker node's external IP address. So if you know the external IP address of a worker node and you know that node port, you can now access your application from outside of the cluster. But that's still not good enough because you don't want to be giving out IP addresses and random ports, right? And so that's why we have this type of load balancer. And so if I do a get service again, hopefully we have an external IP, and we do. So what this has done is Kubernetes, the cloud controller manager, will actually go out to your cloud. This is in Google Cloud, and it will configure a load balancer in that cloud to talk to the node ports on the worker nodes. And so that means that if someone knows that IP address or a DNS name I've pointed to that IP address, they can now access my application without any trouble. So let's make sure, let's kill that port forward. And so we can look at that IP address, and it's on port 80, so we can just run that. And you can see there again, that is the hello Seoul. So that's how we make our applications accessible from the outside world, and also how we control what applications are or are not accessible from the outside world. Because not every application should be available via a load balancer. For example, if it's a database, you don't want to expose that to the outside world. So that's services and networking. Next is volumes. So volumes are pretty simple, really. It's just a directory that is mounted into every container in a pod. It can either be a directory from the local host, which isn't all that useful because these pods should be able to be come and go as they need on different hosts. So usually you would use a shared network device like in the cloud, like Google Cloud Block Storage, or if you're in your own data center, use the VMware shared storage, or use NFS or something else. And that way, if you want it to, you can create what's called a persistent volume, and that will follow your pod using a thing called a stateful set, which is like a deployment. And so using a combination of a stateful set and a persistent volume, you can actually safely run databases like Cassandra inside of Kubernetes. And if, say, you have a 4-node Cassandra cluster, if one of them goes offline, a new one will be scheduled with the same name, with the same disk attached to it. And so you don't lose anything, and you're immediately fixed back to where you were without having to re-replicate all of the data or anything like that. You can also create volumes from config maps and secrets. Config maps and secrets are key value pairs in a Kubernetes manifest that you can either create from a literal key value like this, or you can create them from a file. And they can be exposed to your application either via environment variables or via files in a volume. So if we were to pass this in, we could get an environment variable called message with the contents of hello S1T. But you also might want to do it as a file. So here you can see we're creating a config map from a file. And so what happens is the file name becomes the key, and the contents of the file becomes the value. And so this can then be mounted into any pod, any container. And that means if you have config files or something like that need to be that you need to configure your application, you can do that via config maps. Secrets are like config maps, except you can't read it. It's not encrypted. It is base64 encoded because you might have a binary secret. Encryption is coming. You can use tools like HashiCorp Vault to get encryption, but pretty soon we'll have encryption by default for secrets once the code gets through the Kubernetes release process. So that's kind of my very quick primer into Kubernetes. Unfortunately, we don't have 4 hours, otherwise I would happily talk for 4 hours on it. So we'll move on to Spring Cloud Kubernetes and some of the integrations you can get between Spring and Kubernetes. So when you use Spring Cloud Kubernetes, you get service discovery, client-side ribbon discovery, you get a dynamic config server, you get profile auto configuration. So when you run a Spring app in Kubernetes with Spring Cloud Kubernetes enabled, it will auto-detect that it's running in Kubernetes and load a Kubernetes-specific profile. It's also aware of service meshes like Istio and provides pod health indicators so that Kubernetes is aware that your actual application is running and healthy, which is quite important. And so you get all of these things basically just by including Spring Cloud Kubernetes. So, for example, with service discovery, I've kind of broken up. You've got your POM up the top, and your application. And this is really all you need to be able to have basic service discovery. You don't need Netflix's Eureka or any of that because Kubernetes already handles that service discovery. So it's just tying directly into the Kubernetes API to provide that. And then you can tie that into the Spring Cloud Kubernetes ribbon to do the client-side ribbon load balancing. And so when you have those two tied together, this is literally all you need to do to run an edge application that will load balance for a bunch of your other applications, which is it's great. You can write an application this small to be your edge or your gateway. Spring Cloud Kubernetes also supports Kubernetes native service discovery. And that's because Kubernetes does service discovery using DNS. And so you don't even need to contact the Kubernetes API to get that sort of service discovery. You can simply do DNS lookups. And so we're moving towards this being the more focal part of how you do service discovery in Kubernetes. You would use the former if you're also doing things with things that are outside of Kubernetes and you need to have a unified service discovery. You can also use Kubernetes as a config server. So I mentioned config maps and secrets. And so when you use Spring Cloud Kubernetes config, it will use those config maps and secrets as a config server. So again, you don't need to run an external config server. You don't need to have config settings in Git or somewhere else. You can have them all inside of Kubernetes. And this is how you would, if you have your Kubernetes profile as a YAML file, you would have it specified like this. And you can specify multiple config maps, multiple secrets, so you can get quite complicated in how you do it. And in the config maps or secrets, you can provide an entire application.properties or application.yaml, or you can provide just the keys and values. And then while it's not Spring Cloud Kubernetes specific, you also have Micrometer Registry Prometheus, which gives you a Prometheus endpoint to your application, which gives you automatic metrics collection for your application with zero work. So if you have Prometheus running inside of your Kubernetes cluster, just by enabling this, Prometheus will automatically start collecting all sorts of interesting Java metrics from your application without having to do any setup or configuration work at all. So it is super useful and something I use a lot. And this is kind of the sort of metrics you get. So information about the heap, the uptime, all that sort of stuff. And there's hundreds of metrics. I think there's like 140 something metrics that are collected just by enabling that actuator. So we can actually jump through a couple of things. So I have an application that is like a 4-piece microservices. It's emulating a shop. And so if I look at the very base of it, you can see I have this Jib Java image builder tied in to make it easier for me to build images. And then I have a bunch of different applications. I have fashion bestseller, hot deals, and toys bestseller, and then a gateway. So if we look at the fashion bestseller pom.xml, you can see I have Spring Cloud Kubernetes, Spring Cloud Starter Kubernetes, and Spring Cloud Starter Kubernetes config, as well as the Micrometer registry. And so that then will enable those things for me. And then if we look at our application kubernetes.yaml, which will be automatically loaded because we're running this in Kubernetes, you can see that we have, first of all, obviously, we're making sure that our Spring Cloud Kubernetes stuff is enabled. We make sure we have a management endpoint restart enabled so that when a config map changes, we can automatically update our application. And then we're also disabling Eureka, because obviously we don't need that when it's running in Kubernetes for service discovery. And that is really all we need there. And then if we look at our application itself, it's a fairly basic RESTful endpoint. You can see I'm pulling a value called products. And so if I don't have anything set, it will default to some very simple types of clothing. And I'm making that available via an API endpoint. So it's all quite simple. And so we're going to go ahead and have a look at that application. So you can see we have a bunch of stuff running. Maybe easier to just look at deployments. So these are our deployments. We have the 4 applications. Because we have a gateway, we'll access all of our stuff through the gateway. And do I have the gateway? I don't. And so the gateway is simply looking at Kubernetes using the service discovery and the ribbon client side and basically translate the service names into something that you can access via that gateway. And I'll just do a port forward into it, and we can actually start exploring the shop itself. Okay, we're going to focus on this fashion bestseller. So let's do a curl of that. So basically, where we're doing fashion/bestseller, so the service name is fashion, and so that's how that first part of the URL is being resolved. And then bestseller is the API endpoint inside of that. And so you can see I have these responses. I have a fancy pants, a fancy shirt, and fancy socks. And so if I look at this config map, I have fashion bestseller spring. You can see we have a couple of things going on here. We have Chaos Monkey enabled, which means if I keep hitting that REST endpoint, occasionally it will cause a failure, which will make sure it flips through to my circuit breaker and gives me a valid response from an end user perspective, rather than just giving me a hard error. And then we have our list of products, and you can see they're listed as fancy pants, fancy shirt, and fancy socks. I'm not very fancy, so I'm just going to make them regular pants, regular shirt, and regular socks. I will save that off, And we'll immediately look at our list again, and you can see it's already updated it. It's already changed in the application itself, and it happened very quickly. So if we look at our logs, so you can also run this Kubernetes logs command, and it will show you everything that's been happening in your application. So let's look at this. And we'll actually see where we have refreshed. So you can see basically here, there's our property source, and you can see that it has detected a change and is using a refresh strategy. So I don't need to restart my application, I don't need to restart my pod, because Spring is smart enough to automatically refresh just the part of the application that is going to change because of the change in config. And so that's why that happened so quickly. Now we only have 4 minutes left, so I think we might call that done. So thank you so much. If we want to, we have time for questions, or we can just move on to the next speaker. Does anyone have a question? No questions? Either I did a very good job or I did a terrible job. Thank you so much.